Hi everyone, and today we are going to do something very interesting topic of digital image processing, which is called image restoration. So, definitely before starting anything, we should know that what that term basically means. So, I'm thinking of restoration term, right? Okay. Uh, just suppose that there's a house, a very beautiful house, and what happens to it is that an earthquake arrives and it just destroys everything. So sad enough, okay, the house is destroyed. But what we can do is we can reconstruct the house. We can restore the house back to the original house. So we'll try to build that house again just like it resembles the original one. Quite possible that if we have very, very, very good people working, then those laborers can just turn it same as original, but those laborers need to have knowledge about it. So if they have exact knowledge about how the things were in the house earlier, they'll make it ditto same as original, right? I'll just say please listen to this analogy very carefully because I'll be relating this thing later on. Even trust me, you will definitely be able to get the things very clearly if you remember this analogy. So, as I said, more that person has a knowledge of the house, how it looked earlier, then he'll be able to reconstruct it and restore it again to the norm, like original one. So he just need to have knowledge about it. That's all. So, more the knowledge, more it will be close to the original one. Lesser the knowledge, it will not be, near to the original one. So, now coming on to image restoration. So, now we will be basically restoring the image. So, what is the earthquake in the image? Like, come on, like, what is something which I'm restoring, right? The destroyed house, I'm restoring it. Image, what's the earthquake into it? Do you see one thing over here? This image? This is called a degraded image. Like I say, house after earthquake. This is the degraded image. The image which has been degraded by something. Degraded by what? Yeah, I'll tell you, right? So I need to reconstruct it, restore it so that it looks somehow like this. So, but hey, what just happened over here? Like, I'm not able to get this. What if I tell you that your camera captured this image? You'll be like, oh, so stupid. I never saw that my camera is capturing this kind of image. My camera captures this kind of image. You might be using a very low quality thing. So it's, wait, let me tell you what happens. It's a very interesting thing. Nobody will believe that the output of the camera is this, but okay, in your gallery, this is something which you'll get. How this happens? Very interesting. See, what happens is that in your camera, definitely there's gonna be some noise which is gonna, the earthquake is basically the noise or the degradation model. Now you'll know about how noise and degradation model will destroy this image, but as of now just think that these are the two things, noise and the degradation model, which are destroying my image. So my camera gives the output as this image. But what the magic happens that I'm getting this image? The magic is nothing but there is already the internal circuitry, internal mechanism which takes place inside your camera, which converts your this image into this image. So, like you might have noticed that DSLR, it kind of captures the pictures which is same as that of the original ones, nearly same as that of original ones, because there they have better mechanism for the image restoration. So as you will move like in the mobile is not that it's just about to function the image capturing, it has to do other things also, it has to do calls also, your texting also, your WhatsApp and all those things. So it's not that they are 110% investing into camera thing, right? But DSLR, it is its whole purpose is only to capture the recordings, the images and all. So what happens is that they're investing in the image restoration. So that is the reason that you see this image, but actually the output of your camera is this, but the inside mechanism is converting it into this thing, right? So, okay, if now I am supposed to study this, how will I study this then? Basically, we'll be intentionally introducing the noise, we'll be intentionally degrading it, and then we'll be applying the certain restoration techniques, and we'll see that how much we're able to get closer to the original one. Right. So if you read the definition over here, the image restoration attempts to restore or reconstruct or the recover images that have been degraded. So it identifies the degradation process and then attempts to reverse it. So remember the analogy again. I said as you know how the house was built, if you see that okay this was something, so you kind of make it closer to the original one. Similarly, if you'll know that hey this is the thing which has degraded it, then identifying that degradation, I'll just try to reverse it. For example, like you have water, right? You just cool it down so that it became ice. So once you know that okay cooling was done, which converted water into ice, what? Okay, identified. This is the cooling mechanism. I'll attempt to reverse it. What is the reverse of cooling? Heating. I'll heat the ice cubes and I'll get back water. So that is what I'm trying to say over here, that we need to identify the degradation process which has done it. Then after we are once known with the degradation process, we'll try to reverse it. So more we know about the degradation process, more we'll be able to bring back the image to the original image. So definitely if you're coming on to image restoration, I assume that you people have already studied about image enhancement, and that is why you're coming to image restoration. One thing to note over here is that image enhancement, this is also kind of image enhancement, but this is something more objective over here. Like we used to say that image enhancement is subjective thing. It is something which is related to like user's perspective, or like supposingly some image may look good to me after image enhancement and you it may just appear horrible to you. So image enhancement is totally subjective. There are no parameters to see the goodness of image enhancement. It's all about different perspectives. I may dislike it, you may like it. You may dislike it, I may like it. But image restoration is totally objective. We have a certain criteria to know that okay, this is more better restored, this is not restored. All those things will be taken into picture. But as I again say, you may be a little bit unclear about the things right now, but they'll be totally get cleared as we move further. So we already talked about this thing, that image restoration is nothing but that we need to restore, reconstruct or recover the image that has been degraded, and after once we know the degradation model, we'll try to reverse it. That's all what we have talked till now. And this is again the same thing which I told to you, that restoration will attempt to reconstruct or recover the image that is degraded by using a priori or estimated knowledge of the degradation phenomenon. So in the restoration process, you are going to model the degradation and then apply the inverse process in order to recover the original image. So these are just the repeated things which I already said to you. So this is an diagram which will perfectly explain to you what all is going inside and what all we covered in the last 3 PPTs, right? So we have an original image which I'm denoting it with fx comma y. So that is my original image. So what happens to my original image is that there is some degradation function which happens onto it. Now degradation function, like okay, in your image enhancement you guys have done filters, correct? Let us assume that there is some average filter. So when I apply that average filter on my photo, so at that time, my average filter is my degradation function, right? So that is the first step. Like if you see further over here, this is my original image, and like the example which I'm assuming, right? So this is the equation. We'll be again looking into this equation. For now, this is the original image. So what I have done is that I have just applied that averaging filter. So this is the degradation function I have applied to it. This is the first step which happened. The second thing which happened is that I have added the noise into the image. There was one degraded image, like I have applied my filter onto it. Now what I'm doing is that I am adding the noise to it. So when I'm adding my noise to it, this is further gives me final degraded image, which is denoted by gx comma y. So please note over here one thing, that noise is additive. So this whole gives me this equation that gxy, which is the final degraded image, is equals to h of x comma y, which is my degradation function, into f of x comma y plus noise. So okay, I have just said you that h of x comma y is my degradation function. Like for example, the mask which you are using, right? Smooth, like average mask. So there it was doing smoothing, but here in my image restoration, this h of x comma y, this smoothing filter is acting as my degradation function. And then afterwards, when I add certain noise to it, so here the operation which is happening is convolution, correct? And then this is noise, and this is the equation which I'm getting in spatial domains. Like you know that we basically deal with spatial domain and the frequency domain. These are the two domains which we deal with, but as of now we're just talking about spatial domain. So what is the noise? Noise is just like a random number, right? It's nothing but a random number. Say any random number. Okay, guess, just fast guess in random number. Say I guessed 7. Okay, I had an image, I applied the smoothing filter to it, the average filter to it, then I added 7 in all the pixel values, right? And make sure that the intensity ranges between 0 to 255, and if it's beyond 255, then we have to clip them or we have to normalize them, but that's a later on thing. But as of now, just for the understanding, assume that after doing all this thing, the it still is in the range from 0 to 255. So I just did that, right? So this is the whole process which is undergoing, which is uh, till here. This is the whole process which is occurring for image degradation. Whole thing. We have a function f of x comma y. We'll be applying certain degradation function to it, which is x of x comma y, and then at last we need to add the noise to it, which will give me final degraded image as g of x comma y. So the degraded image in the spatial domain is given by g of x comma y is equals to h of x comma y convolution with f of x comma y plus noise. So this is the additive noise term, this is the degraded image, and h of x comma y is the spatial representation of the degraded function. Now why are we going to saying it spatial, spatial, spatial again and again? If you remember, your filter over there was a spatial filter. Why spatial filter? Because you were just moving around the mask and you were just multiplying and then adding the result for one pixel value. So it was depending upon those pixel values, right? So that's the spatial thing. So once this whole process is called degradation, now this is what outcome comes from the camera, right? Now inside only, like in the camera, this is the whole mechanism. Like if I have a box, right? Like sorry, so if I have a box, correct? Okay, just give me a minute. Like supposingly if I have a box to draw all this thing, yeah, so everything inside the box over here right now will be what happens inside the camera. So till here, up to this point, I was just having the degradation going on. Now, what happens is that after the degradation has taken place, I'll be applying certain restoration filters, and after the restoration filters, I'll get this as the image f like cap or f hat x or comma y. So my objective of the restoration is that I have to obtain an estimated f of x comma y of the